Hey you guys, this is Mr. Sal. We're going to have a quick lesson on approximating the value of irrational numbers. Thanks for watching. So these are problems that were like one on the test. After we reviewed the test, this was the second most missed problem, and only about 80% of you got it incorrect. So we're going to go through these two examples, which were like the one on the test, and do these, so hopefully you'll feel better about doing them. So writing equations, these both are going to work the same way. We only need two things for each equation, and that is the slope and the y-intercept. So each of the equations, we're just going to write this out. Y equals the slope, and we'll fill that in, times the x, plus the y-intercept, whatever it is. So we'll do the same thing on the other one once we get there. Let's do this first one, number one. First thing I'm going to find is the slope, because I just need to choose these first 2 points right here, okay? Now, you could use the formula if you want. We'll do that on number two, actually, but I'm going to use the old-fashioned method. That's just to find the change in the y's and the change in the x's. Remember, the y's are the rise, and the x are the run. Not the runs. That's a whole different thing. So, the rise on this one, see that it goes up from 9 to 18. That's up 9. So the rise is 9, and it's rise over run. The run went to the right 1. So it's really 9 over 1, which is 9. So that is our slope, 9. The last thing we need is the y-intercept. So next up, I'm going to have to go back in the table. So instead of going to the right 1, I'm going to have to go from 1 and go to the left 1, which that means that's the opposite direction. That'll give me 0, which is what we need. And that means from the 9, I've got to go down 9 instead. And that would give me 0. So the ordered pair for the y-intercept is 0, 0. Again, we were looking for where the x is 0, like this. 0, 0. So I'm just going to put the plus 0 right here. Y equals 9x plus 0. Of course, if you wanted to, you could write y equals 9x, and that would also work. Let's do the next one, but I'm going to do it a little different. So to find the slope, I'm going to use the slope formula. So I'm going to use these two y values, that'd be 12 and 24. And then I'm also going to use these two x values, which are 1 and 2. So when I subtract these, 12 minus 24 is negative 12. 1 minus 2 is negative 1. When I divide that, I get 12. That's my slope. And again, that was from the formula. So the slope is 12. What I need to do now is find the y-intercept. So I'm going to show the slope as 12 over 1. So that would be up 12 to the right 1. But I can see from the x value that I've got to go to the left 1, or negative 1. And if I do that, if this was negative 1, then 12 would also have to be negative, just like we saw originally right there. So I'm going to go down 12. So that'd be 0, 0. So again, it's a plus 0 right there. But again, if you wanted to write y equals 12x, that's okay. Take 30 seconds and copy this down. This is the objective for the first part of the lesson. I can accurately estimate values of irrational numbers. So irrational numbers would be, just like we discussed in the last lesson, pi, or the square root of any non-perfect square, such as 2, or 13, or 27. These are non-perfect squares, so when we take the square root of them, we get some kind of horrible looking decimal, which we hate because it's so ugly. Now there's one last part of this objective which we should include. We need you to be able to accurately estimate values of rational numbers with a calculator. So a calculator will be necessary in this section, actually the next one as well. So far we have seen that we can show the location of an irrational number on the number line. We also know that we cannot show the entire decimal expansion of an irrational number because it is infinitely long and there's no pattern. Again, that is because it never repeats or terminates, as far as we know. However, we can come up with good approximations for the numerical value of an irrational number using a calculator. So this is an example that it gives us. So you could just type the value pi, because there's a pi button on the calculators that we have in class. You just type that in, push enter, and it would give you the decimal, kind of like it's showing right here. So what they've done is they've placed 3.1, which is about just a little bit after 3 there on the first number line. Then they've expanded this here like this. And then we're kind of zooming in between those two values, and they've split it up into tenths. So rounding that would get 3.14. So notice this point is just a little bit, almost halfway anyways, between 3.1 and 3.2. But then we expand this one as well. And we split those up into tenths, or in hundredths now. So that'd be 3.141, or 15, which is almost 3.142. So that's why it's just almost, it's pretty close to right after that 3.14 right there. But then they've expanded it again and split it up into the thousandths. And we can see 3.14159, that would round to about 3.1416. So it's not right halfway between there. It's a little bit after that, because again, that'd be about 3.1416 because of the rounding. We can imagine continuing this process of zooming in on the location of pi on the number line, each time narrowing its possible location by a factor of 10. So that's tenths, hundredths, thousandths, and so forth. Once we have an approximation for an irrational number, we can approximate the value of expressions that contain that number. For example, suppose we were interested, for some reason, in the approximate value of 2 pi, because 2 is better than 1. We can use our approximations of pi from above to approximate the value of 2 pi to different degrees of accuracy. Well, here's what we know is that pi, it's about, have you guys seen these wavy equal signs like this?
Yes.
That means that it's an approximation. It is not exact, but it should be pretty close. So pi would be 3.1415, and I think that's all we need-ish. So, because pi is between 3 and 4, 2 pi is between which two numbers? Well, if pi is between 3 and 4, 2 of them would be between 2 of each of those. So 3 times 2 is 6. 4 times 2 is 8. Automatic, we know that 2 pi would have to be between those two numbers. But continuing, because pi is between 3.1 and 3.2, 2 pi would be between 2 of each of those as well. So that'd be 6.2. And also 6.4. So we can see just by going into the tenths values, we have narrowed the range down quite substantially. Next, because pi is between 3.14 and 3.15, 2 pi would have to be between 2 of each of those. So that would be 6.28 and also 6.30. So again, we're narrowing that gap between, or where the value of pi is, and we can continue this process to the next one. Because pi is between 3.141 and 3.142, 2 pi would be between 2 of each of those. So that'd be 6.282. And 2 times 3.142 would be 6.284. All right, check the value of 2 pi on your calculator. How are we doing with our approximations of 2 pi? Well, 2 pi on my calculator gives me this decimal. So that's rounded, by the way. So this is the value of 2 pi. Again, just that first one, 6.28 is between 6 and 8. 6.28 is between 6.2 and 6.4. 6.283 is between 6.28 and 6.30. And 6.2831 is between 6.282 and 6.284. So yeah, we've done pretty good. We can use the method of guess and check to give us an estimate of the numerical value of an irrational number that is correct up to as many decimal places as we need. That is good to know, except actually, it's not good to know. So we don't want to use guess and check method. The method that we are going to be using is not guess and check. The method we are using is calculator method, which we like. Here are the directions. Approximate the value of the following irrational numbers to indicate degrees of accuracy. You can use your calculator. Let's cross out the rest of that so we don't get it confused. You can use your calculator, that's correct. Thank you. Alright, once again, we are using the calculator. So number one, between which two integers does the square root of 5 lie? Which integer is it closest to? And then we'll fill out this number line, show its approximate location on this number line. So do A through E. We'll give you guys a couple minutes to do that with your neighbor. Talk about it, and then we're going to go over it. Which two integers does the square root of 5 lie? So I've written out, I just did it on the calculator, square root of 5, and I got that value. So that means that it would clearly be between the numbers 2 and 3. Those are the two integers. Which integer is it closest to? Well, if I rounded 2.23 to the nearest whole value, the 2 would keep that 2 in the ones place, a 2. So it is closest to 2, not 3. And 2.2 would be about right there on my number line-ish, something like right there. And of course they've expanded it in C to be just between 2 and 3. So 2.2 is this line right here, but 2.23 would be about right there, that red dot. And then they've expanded it further in D between 2.2 and 2.3. And it is 2.236. So 2.23 right here, 2.236, bam, right there. So that is where those points would be. Use your work from above to approximate the value of the expression 2 plus the square root of 5 to the nearest whole number, the nearest tenth, and the nearest hundredth. Actually, for this one, I'm going to start with the nearest hundredth. So that would be 2.236. And yes, I did go to the thousandths because we're going to be doing some rounding. And I'm going to add the 2 to that. That would be 4.236. So the nearest hundredth would actually be 4.
4.237.
4.2, but the hundredths is the 3.
Oh.
So I'm going to round that up to 4. So 4.24. That's the nearest hundredth. And then I will do the tenths place. And just from the number that I just found, 4.24, that would stay rounded to 4.2. And so rounding to the nearest whole number, 4.2 is closer to the number 4. So these three would be our answer. Repeat the process above to find the square root of 52. We did skip number 2. Find the square root of 52 accurate to 2 decimal places. Place your numbers on the number lines provided each time you increase the degree of accuracy of your estimate. All right, do these ones. Give you guys a few minutes to do that with your neighbor. Go. So again, I put the square root of 52 in my calculator and I've approximated it to 7.2111. So we're going to round this to the nearest whole number first, and we know that 7.2111 is between the numbers 7 and 8. Now you could put the rest of the numbers on here, but I'm not actually so concerned with that. 7.2111 would be about right there on my number line. Well, let's take this to the 10th. So this would be 7.2. So if this was 7.0, this would be 7.1, 7.2, and that would be between 7.2 and 7.3. And I don't really need to go further from there because I know it's between those two. So 7.21 would be pretty close to 7.2, right there. But taking this to the hundredth, 7.21, so I'm just going to use those two values, 7.21 and 7.21. 7.22 and 7.2. Oh, I need more than that. Hold on. That's good. No, I got it. So 7.211 would be about right there. That's good. All right, use your word from above to approximate the value of 3 plus the square root of 52. Here's what I did. I put that into the calculator, and I got 10.2111. But it says to round to the nearest whole number. 10.211 would be rounded to 10. To the nearest tenth would be 10.2. And to the nearest hundredth would be 10.21. Now we're going to use that work to approximate the value of 2 times the square root of 52. So I'm just going to put that in my calculator again. So 14.4222. Let's round that to the nearest whole number. That would be 14. The nearest tenth would be 14.4. And the nearest hundredth would be 14.42. Alright, so that's our objective. Again, I can accurately estimate values of irrational numbers. Again, this should be specifically with a calculator. Alright, that does it for this lesson. I hope you guys it helped you out. If it did, please subscribe to the channel and like the video, and just make a quick comment below. Thanks, we'll see you in the next one. Hey guys, this is Mr. Sal. We're going to look at comparing and ordering real numbers. For the most part, most of these sets that we're going to be comparing and ordering will include irrational numbers. So thanks for watching. Here's the objective for this next part of the lesson. I can compare and order real numbers. Again, we could put with the calculator on this as well. Alright, for some reason it says do not use a calculator. Here's what we're going to do. Is erase the word not. There we go, it's gone there. Do use a calculator for the following problems. Any calculations you may need are given in the problem, even though we can use calculator. So with your calculator, with your neighbor, also order the following numbers from least to greatest. Take 1 minute to do that. Go. So the values we have are the square root of 80. We have 8, 9, 8.5, and the square root of 62. So I'm going to write down the values that I got. The square root of 80 is 8.94. And the square root of 62 I put in the calculator. I got 7.87. So the smallest of these numbers appears to be square root of 62. That would be the smallest one. The next smallest number appears to be 8. So we've used these two. The next smallest number would be 8.5, it looks like. And then the next smallest number would be 8.94, which came from the square root of 80. And then finally, the biggest number is the 9. So we used up all 5 of these. And this is ordered now from least to greatest. Now order these from least to greatest. The negative square root of 13, negative 3, negative 4, and negative 3.5. 1 minute with your neighbor, go. So on my calculator I did the negative square root of 13, I get back negative 3.6. I don't need any more decimal places because none of these other ones do. So the lowest number on this in this list is going to be the highest negative because it's farthest to the left on the number line. And in that case it is negative 4. The next lowest number, or the number farthest left on the number line, appears to be the square root of the negative square root of 13. There we go. So that's this one. The next one would be negative 3.5, which was just a little bit bigger than, or farther to the right than that number. And then finally negative 3. Now, we would need these calculations if we were not using a calculator, but since we are using a calculator, we don't really need those. So part A, put the following numbers in order from least to greatest. The square root of 5, 5 halves, 2.2, the side length of a square with an area of 4. And then B, find a number between 2.2 and the square root of 5. And then C, find an irrational number that is even smaller than all the numbers in part A. Take 1 minute to do that with your neighbor. Go. So I got the square root of 5 as 2.236 about. And the side length of a square with an area of 4, if the area was 4, then the side length would be the square root of 4, which is 2. So we're just going to order these from least to greatest, the smallest of which is the side length of a square with an area of 4. So that would be the 2. So I don't want to write all that words. The next smallest would be, it appears, 2.2. The next smallest would be the square root of 5, because its decimal value is 2.236. And then the biggest value would be the 5 halves. So that's ordered from least to greatest. We want to find a number between 2.2 and the square root of 5. And we've already seen that the square root of 5 is 2.236. So we're going to write in a value between those, such as 2.21 or 2.22 would work. Either of these would work. 2.23 would work as well. Yeah. Find an irrational number that is smaller than all the numbers in part A. So the smallest number that we had in part A was 2. Since it is not a perfect square, I can just take a square root of it, and I know it's irrational, and it's also smaller than the original value of 2. Also, you could have used the square root of 3, or the negative square root of 500. Pi is too big. Pi is bigger than 2, which is the smallest one, so pi actually would not work for this. Now, if you put pi divided by 2, that would work. All right, use the following calculations. No, we're not going to use those calculations because we're using a calculator again. Order the following numbers from least to greatest. The square root of 50, 6, 7, 6.5, and the square root of 42. And then part B, find a rational number that is smaller than all the numbers in part A. C, find an irrational number that is smaller than all the numbers in part A. And D, find a number between the square root of 42 and 6.5. Take a couple minutes to do this with your neighbor. Go. So the square root of 50 is 7.07 in my calculator approximately. And also square root of 42 in my calculator is 6.48. So ordering these from least to greatest, it appears that the smallest number that we have is the 6. The next smallest number would be 6.48, which came from the square root of 42. And then after that would be 6.5. Alright, so 6.5. Then the next would be 7. And then the final number would be the 7.07, which is the square root of 50. So this is now ordered from least to greatest. Part B, find a rational number that is smaller than all the numbers in part A. So the smallest number is 6. So I'm going to take that smallest number, which is not a perfect square, and square root it. That would work. Anything smaller than 6, though, you could have used the square root of 35, because the square root of 36 is 6. Oh, this one wants a rational number. So since it wants a rational number, I will make the next number smallest than 6 is 5. So anything less than 5 that's rational, you could have used fractions as well. That would be fine. So find an irrational number. That's the ones that we had already. The square root of 6 or the square root of 35. Anything less than 35 in the square root that is not a perfect square would also work. Find a number between the square root of 42 and 6.5. So 6.48 is the square root of 42 rounded. So we'll just use 6.49.
Yeah, I got that right.
That would work. Alright, again, we're using calculators, so we don't need these values. Part A, order the following numbers from least to greatest. The side length of a square with an area of 9. Also the square root of 6, 2.44, 2.4 repeating, and 2.5. And then B, find an irrational number that is between 0 and the smallest number from part A. And then C, find the number that is between 2.44 and the square root of 6. 1 minute with your neighbor, go. Alright, let's look at these values. The square root of 6 on my calculator. So since we have a lot of decimal places on some of these values, I'm going to put 2.449. Since there already is, well, it looks like that would work, kind of. It looks like it wouldn't change. So yeah, that should be fine. Also, the side length of a square with an area of 9. So the square root of 9 on this one, that's the length of a square with an area of 9, that'd be 3. So from least to greatest, looks like the lowest value we have is 2.44 on this one. That's the lowest one we got. That takes care of that one. The next lowest would be 2.4 repeating. The next lowest would be the 2.449. Actually, let's go ahead and put the square root of 6 there. Square root of 6. And after that, 2.5. And then finally 3. So this is listed from least to greatest. So find an irrational number that is between 0 and the smallest number. So we got 2.44 and also between 0. So that we could just use the square root of 2 for that. Or even the square root of 3. These would be irrational numbers between 0 and 2.44. Find a number that is between 2.44 and the square root of 6, which is 2.449. So we'll just put 2.44. That matches. Just a little bit bigger than that. 5. Of course, you could have put a 6 there, or a 7, or an 8, and that would work. Alright, use the approximations. Use the approximations of pi on page 60. Don't worry about that garbage, actually. Just go through these 6 and find numbers between them, or numbers, or figure out which one's larger. But again, just use the calculator. Alright, number between 3 and pi would be something like 3.1. Because pi is 3.14. Find a number that is between 3.14 and pi. So we know pi is 3.1415. So 3.14, that's the lowest. We'll just make it a little bit bigger than that. Of these, which is larger? Well, pi is 3.14, so plus 5 would be 8.14. So the larger of these two is pi plus 5. 10 minus 3.14, which is pi, that would give us something less than 7. So 7 is larger. Pi is 3.14, so 2 pi's would be 6.28, which is bigger than 6.2. So this one is 2 pi. And then finally, pi squared, or 10. So pi squared is 9.86-ish, which means 10 is bigger. Alright, there's the objective again. I can compare and order real numbers. Again, this should be with a calculator though.
Wait, what is pi squared?
Alright, thanks again for watching. I hope this video was helpful for you. If it was, please subscribe to the channel and like the video and make a comment below. I'll see you guys in the next one.